I am Dr. Vikhar, and in today's lecture we will understand how gear train works. This is the part of unit number or chapter number 4 of theory of machines. In previous lectures we have seen types of gears and their working, and here in this lecture we will study what are gear trains. Sometimes two or more than two gears are made to mesh with each other to transmit the power from one shaft to another, and such a combination is called as a gear train or train of toothed wheels. So here you can say it is a alternative name given to it, which is called as a toothed wheels, train of toothed wheels. So gear train, here there is a gear train. We want to see here what is gear train. So what is given here, when two or more than two gears are made to mesh with each other to transmit the power from one shaft to another, such a combination is called as a gear train or train of toothed wheels. So it is alternative name given, train of toothed wheels. It is also called as a train of toothed wheels, and this train is also used to transmit the power from one shaft to another shaft. So it becomes necessary when it is required to obtain speed reduction with a smaller space. So why we require this gear train? It is required to obtain speed reduction within a small space. So here we understood by definition what is gear train and what are the aspects regarding the gear train. So gear train is a train of toothed wheels. Let us see what are the types of gear trains. There are four types of gear trains. One is called simple gear train, second is compound gear train, third is reverted gear train, and fourth is planetary or epicyclic gear train. So last one is epicyclic gear train. It is also called as a planetary gear train. So we understand here one by one the meaning of each type of gear train, starting with the first. As you can see here, first type of gear train is simple gear train. So what is the meaning of simple gear train? When there is only one gear on each shaft, then it is known as a simple gear train. If you want to form a simple gear train, the condition is that there is only one gear on each shaft. If you make such type of arrangement, only one gear on each shaft, then we can get simple gear train. In following figure A, B, C, you will see the different forms of simple gear trains. In figure number A, you will see that there are two gears, gear 1 and gear 2. In this you will see that gear 1 is moving in clockwise direction and gear 2 is moving in anti-clockwise direction. This is a very simple gear train. Second type is also the form of simple gear train, but here you will see that there are three gears mounted on three different shafts. This is a shaft number 1, shaft number 2, shaft number 3, and you will see that the number of gears are 3, odd numbers are given. Between the gear number 1 and gear number 2, you will see that at the middle gear number 2. So this is another form of simple gear train, and one important thing you will see that the gear number 1 is having clockwise direction while the gear number 3 is also having clockwise direction. So gear number 1 and gear number 3 are moving in the same direction, clockwise, while the middle gear is moving in anti-clockwise direction. In the figure number C, you will see that there are four gears, gear number 1, 2, 3 and 4, and in this the total number of gears are 4. That's why you will see that Again, the first gear is moving in clockwise direction, but the last gear is moving in opposite direction, because the number of gears are 4, which is nothing but the even number. So when the number is odd, number of gears are in odd numbers as shown in the figure number B, you will see that the external gears, these external gears, gear number 1 and 3 are move in a same direction, but when the gears are in even numbers, like in this figure number C, you will see that the external gears, this gear number 1 and gear number 4, they will move in opposite direction. So this is a characteristics of this type of simple type of gear train. So after that we will learn here what is mean by speed ratio. So speed ratio we can define here, the ratio of speed of the driven shaft to the driving shaft is a speed ratio. So speed ratio is also called as a velocity ratio. Speed ratio is also called as a velocity ratio. So what is that? It is a ratio of speed of the driven shaft or driven gear to the driving shaft or driving gear. Its value is negative when the input and output gears rotates in the opposite direction, and its value is positive when the two gears will rotate in the same direction. So it is having a positive and negative value. If the value is negative, then we can say that the two gears, input gears and output gears, rotates in the opposite direction. So negative value means opposite direction, and positive value means both the gears will rotate in the same direction. From the speed ratio we can calculate the train value, gear train value. How we can define a train value? Train value is nothing but a reciprocal of speed ratio. Reciprocal of speed ratio is called as a train value. As we can see here in this figure, there are 4 gears, 1, 2, 3, 4. So accordingly, if you see the T is the number of teeth on each gear, and N is the representation for gear speed, then for this figure number C, we can write the equation of the train value like this: omega 2 upon omega 1 is equal to N2 upon N1 is equal to T1 upon T2, and between gear number 3 and gear number 2 we can write N3 upon N2 is equal to T2 upon T3, and between gear number 4 and gear number 3 we can write N4 upon N3 is equal to T3 upon T4. Again I am repeating, for this particular type of gear, which is a simple gear train having 4 gears, for gear number 2 and gear number 1 we can write N2 upon N1 is equal to T1 upon T2. T1 is nothing but teeth on gear number 1 and T2 is the teeth on gear number 2. N2 is the speed of gear number 2 and N1 is the speed of gear number 1. For the another combination which is nothing but gear number 2 and gear number 3, we can write here N3 upon N2 is equal to T2 upon T3, and in similar way for the gear number 4 and gear number 3 we can write this combination N4 upon N3 is equal to T3 upon T4. So by multiplying we can write N2 upon N1 into N3 upon N2 into N4 upon N3 is equal to T1 upon T2 into T2 upon T3 into T3 upon T4. So this is the equation that we get, and finally if you see we get here the speed ratio by cutting all these, by cutting the terms like this: N3 this N3 and this N3 is getting cancelled, N2 and N2 is getting cancelled. Finally, we get N4 upon N1 on the left hand side, and here in this category also on the right hand side we can cut T2 and T2, and this T3 and T3 we can write here T1 upon T4. So, this is the main equation, N4 upon N1 is equal to T1 upon T4. So, it is clear that intermediate gears are no effect on the speed ratio. So, this is happening in case of simple gear train, as this is various kinds of intermediate gears are utilized here. So, gear number 2 is the intermediate gear, or here also in this case gear number 2 and 3 are the intermediate gears. So, in this way we understood here how to define a train value, what is speed ratio. After that, here we can see the importance of providing an idle or intermediate gears. When center distance between the gear is large and we need constant velocity ratio, the motion from one gear to another can be given by the following methods. Number 1 is by providing the large size gear and by providing one or more intermediate gears. So, intermediate gears are called idle gears, as they do not affect the speed ratio or train value of the system. It is also used to obtain the desired direction of the motion of the driven gear. So, when the number of intermediate gears are odd, the motion of the driver and driven is like, and if number of intermediate gears are even, the motion of driven will be in the opposite direction of the driver. So, this is the characteristics of intermediate gear, how that plays a role. So, in that category, speed ratio is defined as speed of the driven gear upon speed of the driver gear, and is equal to number of teeth on the driver upon number of teeth on the driven. So, in this way we have defined here the simple gear train. Now, we will see here second type of gear train, which is nothing but called as a compound gear train. When a series of gears are connected in such a way that two or more gears rotate about one axis with the same angular velocity, it is known as compound gear train. Two or more gears rotate about an axis with the same angular velocity, that is more than one gear on a one shaft is mounted. So, this figure clearly indicates how is the nature of compound gear train. Compound gear train. This figure shows a compound gear train. At the middle, this shaft is in this shaft. On this shaft number 2 and shaft number 3, you will see that mounting of the two gears on the same shaft. So, this is the gear number 2 and gear number 3 mounted on the same shaft, and in case of another shaft, you will see here on this shaft gear number 4 and gear number 5, they are mounted on the same shaft. So, when a series of gears are connected in such a way that two or more gears rotate about an axis with the same angular velocity. So, gear number 2 and gear number 3 are moving with the same angular velocity or a speed, and gear number 4 and gear number 5, they are moving with the same angular velocity, then such a combination is known as a compound gear train. In this figure particularly, you see that this is a top view, and we can observe from this figure N2 is equal to N3 and N4 is equal to N5. N2 is equal to N3 means speed of the gear number 2 is equal to the speed of the gear number 3, and speed of the gear number 4 is equal to speed of the gear number 5. So, by the formula of speed ratio or velocity ratio, we can say that for the combination, this combination N2 upon N1 is between the gear number 2 and gear number 1, N2 upon N1. This combination is between gear number 4 and gear number 3, N4 upon N3, and this combination is in between gear number 6 and gear number 5, N6 upon N5. And for this particular combination N2 upon N1, we can write T1 upon T2. For this particular combination, we can write here T3 upon T4, and for this combination we can write T5 upon T6. As we know, N2 upon N2 is equal to N3 and N4 is equal to N5. So these are getting cancelled. So N2 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 and N3 is getting cancelled, and N4 and N5 is getting cancelled, and finally we get here the equation for a velocity ratio or speed ratio for compound gear train as N6 upon N1 is equal to T1 multiplied by T3 multiplied by T5 divided by this term T2 multiplied by T4 into T6. So T1, T2, T3, T4, T5, T6, these are the number of teeths on each gear. So in this way we understood here how is the nature of compound gear train. After that, this is the third type of gear train, which is called as a reverted gear train which is called as a reverted gear train. Reverted gear train, this is the third type of the gear train, reverted gear train. So third type is nothing but reverted gear train. So you will see that again different gears. This is a shaft number 1, this is a shaft number 2. So first gear is there, second gear, third gear and fourth gear. So gear number 2 and gear number 3, they are mounted on the same shaft 2 and 3, and gear number 1 and gear number 4 are coaxial. They are not mounted on the same shaft, but they are coaxial. So it is the different structure somewhat. If the axis of the first and last gear of the compound gear coincide, that is driver and driven gear are coincide, then it is called as a reverted gear train. You will see that this gear number 1 and this is gear number 4. Gear number 1 is a driver gear and gear number 4 is a driven gear, and the axis of first and last gear, first gear is gear number 1 and fourth gear number 4 is a last gear. Then the axis of the first and last gear of the compound gear coincide, they are coinciding, not contacting each other, they are coinciding. Then the driver and driven gear coincide, then it is called as a reverted gear train. So this is particular picture of reverted gear train. As you can see, another feature, gear number 2 and gear number 3 are, they are mounted on the same shaft, that's why, and we can write here N2 is equal to N3. So for the first combination N2 upon N1, this we can write here N2 is in contact, N2 means gear number 2 is in contact with the gear number 1. So for that we can write here N2 upon N1. So after that gear number 4 and 3, gear number 4, this is gear number 4 and gear number 3, we can write here N4 upon N3, they are in contact. So we can write the equation for this is N2 upon N1 into N4 upon N3 is equal to T1 upon T2 multiplied by T3 upon T4. As N2 is equal to N3, so they are getting cancelled. So we can write here N4 upon N1 is equal to T1 into T3 upon T2 into T4. So this is the equation of speed ratio or velocity ratio in case of reverted gear train. After that, the last gear train is planetary or epicyclic gear train. So in this figure you will see the structure of epicyclic gear train. In an epicyclic gear train, the axis of the shaft on which the gears are mounted may move relative to a fixed axis. So this is a feature of planetary or epicyclic gear train. So we can understand here this thing from the figure number 4 here. A simple epicyclic gear train is shown in this figure. In this you will see that gear number P and arm, this is arm A, have a common axis, this is having a common axis at O1, this is the center O1 about which they can rotate. So P and arm A, sorry, this is arm A, this is arm A, and these are rotating on the common axis, they are rotating around the common axis. After that you will see that the gear S meshes with the gear P. This gear S is going to mesh with the gear P and has its axis on the arm O2, about which the gear S can rotate. So, what is the condition? If the arm is fixed, this arm is fixed, if you fix this arm, it is stable, the gear train is simple, and gear P, this gear P can drive the gear S. So, if this arm is fixed, then the gear P drives the gear S, or gear S can drive the gear P. But what is the condition? This is a fixed, arm is fixed. If arm is not fixed and gear P is fixed, this gear P is fixed, then the arm, this arm will rotate around this gear like this. Then if the gear P is fixed, the arm is rotated about the axis of the gear P, then the gear B is forced to rotate around the P. So, these are the two possible conditions in epicyclic gear train or planetary gear train. The epicyclic gear trains are useful for transmitting the high velocity ratio with the gear of moderate size and in a comparatively lesser space. They are used in back gear of the lathe, differential gear of the automobiles, hoist, wrist watches, etc. Epicyclic gear train may be simple or compound. So, in this way we understood here what is the meaning of epicyclic gear train and what are the types of gear train. Thank you very much.